Okay, so homeostasis is basically how the body is able to maintain stability inside despite external environments. So let's say we have this graph, right? And right here we have set point. And let's say we have a scenario of like we're in a warm building and we're not wearing a jacket and we step outside and we're out there, and so it's very cold. And so before we leave the building, we're right here. So right here at set point, and that's the desired spot. But it can go two ways. It could either go up or it could come down. So, sorry, this is wrong. So it could go away from the set point or it can go to the set point. So let's do two different colors. So we want this one. This is negative feedback. And this is positive. So negative feedback goes towards set point, which is the desired place that we want to be. That positive goes away set point. So if we put on a jacket, we go to set point. If we don't, we go away from set point. And so there's different things that are happening, and I'm going to label them. So we have a stimulus, this scenario, a receptor, control center, effector. Oh, I'm actually forgetting one. We have the afferent, we have the control center, we have the efferent, and we have the effector. So in this case, the stimulus is walking outside. This would be like a thermal receptor. And it's going from body to brain, sending a signal. And then control center, the hypothalamus or the brain, interprets what's going on. Brain to body. And then an action happens. Like body starts to shiver. And so that's that. Okay, so the second part, it's asking Three types of protein mediated transport. So we have diffusion, through channels. Which is passive. Active and is it active and passive? Yeah, I think I actually, yeah. So here we have passive, and then look, I can actually go back. And then there's two. So we have simple diffusion and facilitated diffusion. And so simple diffusion, it goes this is the example right here. So this is the membrane right here. And then we have like a protein here that is solutes are going through. It never touches these things, the passives. It passes through very quickly in large amounts, and so it's super quick. The main ones are O2 and CO2. But depending on the size of the molecule, it's the rate that it goes. And then facilitated diffusion, this is still under passive. It comes in contact with this. So let's say this little thing goes in here, it opens this things, and then it puts it in here, and then this closes, this opens, and it takes it out. This is slower, and it doesn't happen through large amounts. So there's a slower rate. And so that's that. And one example of this is like glucose tends to do that. Okay, and then we have active transport. So primary active transport, which directly uses ATP. And so an example of this would be the sodium potassium pump. So because it's pushing against its gradient, that's why you need ATP. And then we have the secondary active transport. It indirectly uses ATP. And so Oh, and then these are important. The mechanically gated channels. So mechanically gated channels, depending, like let's say we have like a membrane right here. This is like a thing. If the membrane is pushed or moved around, it opens or closes. Mechanically gated channels, they open through ligands. So this is closed, but if something attaches, it opens. Voltage-gated protein channels. Oh yeah. These are always open until it reaches equilibrium. So there's that. And here we have to talk about tonicity. So tonicity is very interesting. Tonicity and osmolarity. So actually, let me go back to this one. Okay, here we go. So, osmolarity measures total particles per liter solution, and tonicity describes how solution affects the firmness of a stretch. So, if we go back to this unit, here we have, so we have, these are the examples. So we have 9% saline, which equals to 300 milliosmoles. We know that in the cell we have 300. So here we have 300, and here we have 300. And so right now they're both the same. So it's isoosmotic. And then for tonicity, we put them both here, and they're also both the same thing. So this is isotonic. And then for dextrose, it's 5% dextrose equals to 300 milliosmoles. So we have 300 here and 300 here. So this is isoosmotic. And then when we put it in here, this dissolves, the dextrose dissolves, so there's more saline in the inside, so it becomes hypotonic because there's less outside. And for this, and so that's basically what it is. And so